You may have heard of Retrieval Augmented Generation, also known as RAG. RAG offers a new way to optimize large language models and produce more accurate, context-aware, and informative responses from LLMs. Next up, you'll see RAG in action in a workshop delivered by three speakers: Juan Pablo Norena from Canonical, Ron Abellera from Microsoft, and Akash Shankaran from Intel. Juan Pablo has a master's in electrical engineering and over 6 years of experience in technology solutions, architecture, and infrastructure. Ron is a cloud architect, business, and community leader at Microsoft. He has been helping customers migrate to Azure and run more Linux workloads in the cloud for the past 13 years. And Akash is a lead software architect at Intel working on the OpenSearch project. Let's get started with their talk.
So today we will present quickly build and deploy LLMs with Retrieval Augmented Generation. With me, it's Ron from Microsoft, Akash from Intel, and we will cover some topics of interest today around this idea, being able to build your own LLMs and get the most out of it through the RAG methods to be able to be more precise in your answers and enhance the production grade, enterprise grade of your LLM applications. I will start talking about a small introduction to LLMs. Then I will pass the word to Ron and Akash to complement from the Azure and Intel perspective on this topic. So I would like to start introducing LLMs. So to the question, what is an LLM? LLM, it's a huge advancement in technology. It's been the topic of the last year, this year, around generative AI. It stands for large language models. It's a set of foundational models that allow us to interact with our natural language and basically get the computers to understand us and be able to respond accordingly, to adapt it to your day-to-day task. It can be in your personal life, it can be in your work, and probably you've been already interacting with LLMs. So there are very popular foundational models out there. We have big names like ChatGPT, Cloud, Copilot, Gemini out there, and probably you have been using them for, I don't know, you have some ingredients in your fridge. ChatGPT, Cloud, Copilot, help me to build a recipe for this night, or even at work, you can have some reports and trying to get a summary from that report, and you adapt it to your needs in your day-to-day. So LLMs can be very helpful tools, but they have gaps. They have gaps when you try to use them in an enterprise environment, in a work environment, where you not only need them to provide you answers, but you also need precision, and you can't compromise the security that comes along it. So we can identify two critical problems when you plan to use LLMs into work to boost your productivity. And the first one is going to be precision. So I would like to build a scenario here. Imagine that you're getting pulled into a meeting without a proper contextualization from your manager. He or her is asking you a very specific question about something that it's critical for the conversation. And since you're a sharp professional, you probably will first figure out a broad answer that you can provide from your expertise on the spot, or just being transparent and say that you don't have enough information to provide that answer. And in that scenario, the lack of context can compromise how precise you can be on the answer you will be providing. And it's the same for LLMs. So in this scenario, you're trying to be as helpful as you can. When you're using an LLM at work, you're trying to build an assistant that it's as helpful as it can. And in both cases, rushing to provide an imprecise answer can be misleading for the conversations or the tasks that you're using LLMs as tools. So LLMs are trained and retrained and fine-tuned for specific tasks. Sometimes their training can come become all updated. They may not encompass all the information or all the necessary information that you have, which it's a crucial aspect to be aware when you are using LLMs to help you in your work tasks. And that's when RAG comes into play. So RAG, it can be thought as a methodology to enhance the precision of your answers without having to retrain or fine-tune your model. So we can say that in the scenario of the manager, RAG is the equivalent to receiving an email ahead of that conversation, ahead of that meeting, in order to get the required information that you need to get the proper contextualization, prepare the meeting, and be as helpful and precise in answering that question that will put you on the spot. So in order to be able to implement RAG, we will need the ability to ingest, store, search, and retrieve information. And that's the basics of RAG. But apart from that, we will need the capability to manage that information as sensible information. We will need to put some tools around it, like role-based access controls and a lot of things that will allow you to make this RAG method something that it's enterprise grade. It's ready for production. So using RAG can be the difference between having an unprecise LLM with having a precise and helpful LLM that can provide answers rather than precise answers rather than broad generic answers. Even can prevent the concept of hallucinations in LLMs, that it's something very important when you're driving a solution like this in production. So I already mentioned the first challenge, precision. So with RAG, we can tackle precision. The second one will be around something that I already mentioned, and it's going to be confidentiality. In the same scenario, the conversation, it's probably also confidential. You are talking with a customer. It's the information that you're exchanging there, it's sensible. And probably when you want to exchange that information, you also use the allow it and proper channels to exchange that information. So you don't have any risk of leaking information and having a very complicated conversation with the size of your company. So in this case, let's suppose that information is going to come through email and approved channel. Let's think on the LLM case. So the basic of RAG, it's you providing context to the LLM as part of the prompt with the information the LLM will need to get the insights out and be able to provide a precise answer. But when the information that you are putting in, it's maybe a classified financial report, classified information about an upcoming product or something like that, and you are providing this information to a third-party LLM outside your organization's control, you're probably compromising the confidentiality of that information. So that's the second thing that a proper end-to-end RAG workflow can help you. So if we insert the LLM under the organization's control, it can be in the public or private cloud. You build the RAG workflow, so the ingestion and everything happens through secure channels. RAG is there to help you to enhance that security component on the end-to-end RAG workflow that you're trying to build. So at Canonical, we have two powerful solutions that you can leverage in order to build your end-to-end RAG workflow. So I will mention both of them. The first one is OpenSearch. It's a search engine that's very popular recently under the Linux Foundation control. It has very strong database capabilities and a basket of machine learning tools to leverage complex solutions around NPL, but other machine learning workflows, or improve the tools that your scientific data scientists and data engineers have to leverage these kind of solutions. As long as with all the other things that we expect, we have fine-grained access control to the different resources and a set of things that you can put around monitoring so it can be production ready. The second one is going to be Kubeflow. Kubeflow, it's a platform that helps you to optimize hardware resources like GPUs, and others. So you can use a set of tools and frameworks to provide a complete ecosystem to your data scientists and each stage of the ML life cycle. So in the life cycle of the RAG end-to-end workflow, we didn't mention the ability to get the feedback from the user in order to build a fine-tuning pipeline for the LLM that you will be inferring and others. So for the specific case of RAG, and the demo we will perform later, we'll be using OpenSearch as the front-end API for the conversational applications you will build. Thanks to that airbag capability, it will provide enhanced security to the access, to the context, to the indexed documents, to what you can consume or not from the different tools around. We'll use OpenSearch as a vector database, and it will provide KNN indexes in order to build sentence transformer pipelines around it, store the data there, be completely sure that our data is securely stored in these indexes, and some additional capabilities like building a memory index to store the conversation history and being able to provide that conversational flow that you expect from a modern LLM application, a connector to the LLM API, so you can connect it to the LLM that you're inferring in this case in your environment, but also connect a third-party LLM in case you want to load balance or route different RAG agents depending on the task that they are performing. And finally, provide a guardrail filters for the inputs and outputs of your RAG interaction with the users. Then we will use Kubeflow as the inference server, and we'll use that inference service that it offers to serve that LLM. Not only that, Kubeflow also has Istio. It will provide the all routing of the traffic between the gateway and that specific component model that you are inferring. Build a queue proxy for the different requests. It's not the same when you have a couple of users interacting with your LLM, when you have hundreds of users with thousands of questions per hour. And all that, we will use a particular component, KeyServe, to serve the LLM that will offer us a OpenAI compatible chat completions API to build our application. So we will come back into the architecture when we get to the demo. So I mentioned some of the capabilities of each tools in the RAG architecture. With these open source solutions, we'll specify which role takes each of them in each part of the process, each part of the architecture. I will pass the word to Ron from Microsoft so he can tell us why Azure Cloud is the right platform to run our RAG workflows. And the word is yours.
All right. Thanks, JP. So thanks for having me. And I'm Ron Abellera from Microsoft, as I mentioned previously. I work with a lot of customers. I've been working on the Azure platform since the very beginning. So I've had the pleasure of working with a lot of customers on both migration and modernization to Azure. And the whole AI piece of the puzzle is just yet another key cornerstone of why customers are looking at Azure. So especially when it comes to large language models and RAGs deployments, we're running into those conversations and helping customers on a daily basis. That this is an absolutely hot topic for our customers. So why do customers want to run these on Azure? So next slide, please, JP. So the good news is that all the technology and architectures that we've been talking about today so far in this webinar is really all can be hosted within Azure, right? All the different components, all the compute requirements and networking and data sources, customers are already doing that within the Azure framework already. That's the good news. And we are seeing a lot of benefits on being able to have it holistically in the cloud and having, your data in disparate places, because, even Microsoft, we use RAGs architectures even for our internal processes. And one of the key learnings that we've had is that, hey, You want to be able to keep things secure. You want to keep things performant, and you want to be able to reduce the latency. So everything is a good experience for customers. So all the components that you see here on this slide, right, runs on Intel VM, SKUs on Azure, right, and the storage and the networking. So I'll give you some specific reasons why customers are leveraging Azure for that. And so we'll go to the next slide here. A lot of it just depends on security and the compliance, and just making sure that we're checking all the boxes from a requirement standpoint for our customers. Many times there will be an initiative to create like some sort of AI IP within a customer, but then the security teams want to make sure that's protected. It's not accessible to the public or not accessible to other customers, etc. So it's really important that all these best practices when it comes to security are in place. And the good news is that from an Azure perspective, a baseline security model for Linux workloads. So all these components that you see from running your OpenSearch cluster or running your Kubeflow cluster on Azure, right? They're all going to be on a does start off with like the network isolation piece. This is really critical for a lot of security teams, is that, hey, you need to make sure that you have your own island, so to speak, right? Your network isolation, both from, the external world and also even from internal. If there's, RBACs in place from other organizations within a certain company that can't access, that type of IP. So making sure that you can create, VNets in Azure just for your specific environment, for your LLMs and your RAGs, will allow customers to be able to quickly deploy your OpenSearch and Kubeflow clusters at scale and pretty quickly as well. Customers are also concerned about not only, about the networking, but also how about the data, data at rest and data in flight. So that's the good news about Azure, is that, there's encryption at rest as well as encryption in flight. We support the various, the latest, network encryption protocols, including TLS 1.3 out there, and even a lot of the storage options that we have, have encryption built in as part of the underlying architecture. So you can enable those and have, you can even add another layer of encryption if you'd like, but those capabilities are already built into the platform. The other thing we'll talk about here, even later in this webinar, is that there's just so many regions and so many virtual machine types just to even get started. So there's a lot of different Intel capabilities that have accelerators that Akash will talk about later, but those are available in Azure, and they'll also allow you to be able to basically optimize, right, your workloads and your compute requirements for the specific CPUs that can handle it and can not let you scale. So many times we have customers that start off with like, smaller or cheaper virtual machine family sizes, when they're doing that test, right? And then whenever they want to go into production or go global, then they'll choose, obviously a huge amount of those CPUs, and also change the CPU type to be something a little bit more performant, and even have some security features built in as well. So from a performance and scale, I'll show you the number of data centers. It's pretty massive. So you'll be able to take advantage of all the different regions, the networking capacity that we have, all the petabytes of storage that's readily available for being able to incorporate into your RAGs architecture. And just know too, what customers are doing, especially on the RAG side, as JP was mentioning. If you want your query to be contextually accurate, you need to have access to all sorts of data types. So there is a data gravity issue too, which is really important when we're architecting this at scale. And customers are already leveraging things like SQL Server and NoSQL databases like Cosmos DB, right? And using analytics like Databricks and Microsoft Fabric. So there's already petabytes of data that's available, that most companies are already leveraging in Azure today. And you can add that as a component to your RAGs architecture to make your AI models even more efficient and more accurate when it comes to, the result set, right? So, and being able to have that within a localized environment is really important. Is one of the things we learned is that latency is a key differentiator, not only just from a performance and usability standpoint, but also on cost. Imagine if you're trying to do a lot of data transfer from different locations and trying to move the data to your compute is going to be waiting around a long time. And that's a waste of money and power and time, because, the good thing about cloud is that you pay for what you use when you use it. So you can easily turn up compute, thousands of cores at a time, then turn it down whenever you're not needing it. And that saves a lot of cost for the customer. And it also gives you the ability to tap into more compute power on demand. So just like that scale and the fluctuating compute requirements at scale is one of the big reasons why cloud is really the de facto location for most of these AI applications. I'll finish off with the last two on monitoring and compliance. These are also key for developing these new AI applications, because once again, the security teams and all the compliance teams want to make sure that your intellectual property, your IP, is going to be protected, right? So they want to have visibility on making sure that all the virtual machines are secure, they're patched to the latest things, right? They're getting access to only the right amount of data that they have access to, and that sort of thing. So being able to satisfy, being able to monitor the environment, have all the logging in place, which can take up a lot of storage as well. So those are really, really important components to be able to make sure that, you address all the security requirements for your organization, and that will fast track you to get your AI application to production at scale. All right, next slide. So as I mentioned, that scalability, right, and the availability of the different Intel and VM options in Azure is so vast, right? So see, and Akash will talk a little bit more about this, about what, the AVX and AMX and TME CPUs do, but see the corresponding Azure VM families they're associated with, and take a look. There's 60 Azure regions for the various VM types that we're going to display here through our demo. So all these regions have these types of, virtual machines families. So you can start off with, dev test and then move to production, right, at scale. But the good news is that, you can move the compute closer to your end customers to have a better performance. And, the availability of all the different locations it gives customers, that peace of mind is that, hey, they don't have to buy hardware on-prem and wait months anymore. They can deploy pretty much anywhere and get started on their AI project as soon as possible. So Azure, it's a fantastic place. That's why we have customer conversations all the time, and it's really tough to keep up with the momentum. But that's a good thing that customers are finding value in putting the RAGs architecture on Azure. So I'll turn it to my Intel counterpart, Akash, to talk a little bit more about how the Intel accelerators help out.
Thank you, Ron. And before I start, I'll just briefly introduce myself. I am Akash Shankaran, software architect at Intel. As you might have heard from my colleagues in the earlier slides, JP, about the amazing technologies getting built at Canonical and the vast scale that Azure provides, like 60 plus regions, that's phenomenal. I wanted to just give a brief context on the role Intel plays in RAG and how we support the pipelines of the future and the AI workloads that are upcoming. So most of might know Intel as the designer or the hardware manufacturer of CPUs. But a fact that's less known is Intel also has an extremely rich history of making open source contributions. And we have been contributing for many, many years to the Linux kernel, the PyTorch Foundation, PyTorch libraries, and more recently to the OpenSearch as well. We believe in fundamentally enabling technologies at a foundational level, and where possible, we try to do it implicitly so that the users can directly start leveraging the latest greatness that comes with these technologies. And that applies to the accelerators that I will be talking about as well. So our end vision is to have as little application side changes as possible and just ensure that all your libraries are pre-optimized, all the dependencies are running at their best possible performance with all the security guarantees. Everything's already ready for the user to use. So in the reference diagram that you see here, this is the same diagram that was shown previously. You can see that Intel plays a significant role in a lot of the places in a RAG pipeline. For example, there's hotspots of performance we have been improving. There's a huge part which we play in ensuring confidentiality, which was a topic touched upon earlier. And as you can see in the diagram, there's the vector databases, there's the embedding models, there's so many, and there's the inference engine. So these are like very common hotspots, and Intel has solutions, accelerators in place, which is already available at the large scale of Azure and other public clouds that anybody can come and leverage. So I will go over some sample hotspot in the next slide, where we will be looking at what Intel can do. This example will walk us through a hotspot that occurs in the data management portion of the RAG pipeline. So the data management portion is the vector database that is powering the RAG. In this example, this is OpenSearch. So within OpenSearch, when we analyze the stack, we observe that the bulk of the time, as you can see from the graph below, is being spent on index build. In OpenSearch, it's called KNN index, and on the query of the neural search as well. Now, what is happening over here? Essentially, when you hit these stages, there is an in-memory graph that gets constructed. It's called an HNSW graph. For people who are familiar with vector search terminology, this is a hierarchical, navigable small world, meaning you're constructing a graph connecting all the different data points. Now, what role does Intel play here? We found that this is a perfect candidate for that can benefit from certain vectorization techniques. So using Intel's AVX 512 accelerators, which already has support in Ubuntu and also for the Charmed OpenSearch platform, you can directly leverage it to tackle this hotspot. And in some of our experiments, you will see that it's given speedups of up to 35%. Now, what happens under the hood when we talk about AVX 512? That is something worth mentioning. So, for example, when any customer wants to use AVX 512, or a predecessor to this was an AVX2 technology, essentially you're trying to parallelize your computation, not necessarily at the application level, but more so at the data level. This technique is called SIMD for people familiar with this. And the benefit to the developers at the end is by using wider registers and rewriting a small portion of their processing logic. You can actually abstract your APIs and essentially perform what is called data parallel processing. Meaning you can do process parallel lanes of data and then speed up your computation at the same time. So that was a good example of AVX 512 and how it benefited the hotspot in the RAG pipeline for data management. Now, this slide will touch upon the various accelerators that Intel has. There is certainly more than this, but I will touch upon the ones that are more relevant to confidentiality, security, and performance in the RAG pipeline. So AVX, which stands for Advanced Vector Extensions, there is a 512. So AVX 512 is the latest in the series of accelerators. The predecessor to that was AVX2, which uses 256-bit registers. Now, these are very, very useful in workloads that have like a high need for vector-based processing, such as vector search, semantic search, neural search. All of these require vector processing. And this accelerator is very well suited for those needs. And you can see on Azure, they are available on a wide variety of instances, such as the DSV4s, EDV4, EDV5s, ESV6, and EDSV6. So all of these instances will allow you to use the accelerator. There is no extra work that a customer would have to do. all you have to do is go to your public cloud, such as Azure, pick the instance family you want, and just write your application. There's no custom changes needed. Also to note, these accelerators are available for applications written in various languages, such as Java, C++, or your favorite language of choice. Next, I will touch upon AMX, which is another accelerator. This is available with the 6 family, the DSV6 and the EDSV6 on Azure. This accelerator is very, very relevant for more on the ML machine learning and the AI scenarios that require deep learning training and that perform inference on the CPU. So this solution positions Intel in the inference space, where a lot of which is very compute intensive as well. AMX typically operates on matrices. And if you're familiar with the inference problems, like that's a lot of it involves matrix manipulation. AMX leverages the CPU to perform those matrix calculations and multiplications, and thereby giving significant speedups to the inference portion of your workloads. Lastly, I'll touch upon TME, which is another technology and accelerator available on Azure. That stands for the total memory encryption. The functionality of this accelerator is to encrypt all the data that's written to the DIMM. This allows you to defend your memory against any sort of physical attack, like if there's any external or internal attacks to your physical memories, then you could essentially defend yourself and guard your application against all of those external threats. Lastly, I will touch upon Intel TDX, which this stands for Trust Domain Extensions. It is Intel's solution for confidential computing. The way it works is it provides you a hardware-based trust execution environment, also called as a TAE, which is essentially a which provides you hardware isolation at the VM level. So if you have a machine that is enabled with TDX, you could essentially isolate your VM and protect sensitive data from external threats and attacks or any sort of unauthorized access. Even within your organizations, oftentimes there's different levels of hierarchy based on access control. So by using functionalities of that Azure already provides, such as RBAC, you could add a second level of protection at the machine level by using TDX. Now, you might be wondering, why is all this relevant to a pipeline such as RAG? The very first reason I can see is like this is an extra layer of protection. So specifically in environments and workloads which require high level of trust and confidentiality, this will be very valuable. And as I touched upon in my introductory slide, we believe in enabling accelerators implicitly with as little changes to the application as needed. For this particular accelerator, you do not need to make any application programming model changes. Secondly, you can protect your data, your AI data, by providing isolation and integrity and confidentiality. Lastly, this also enables you to run your models on very sensitive information, which has the potential risk of leaking or getting exposed in a non-confidential environments. This is also to note, this accelerator is already available on Azure Cloud. So that was all the accelerators that are very relevant to Azure and which apply to the RAG pipeline. And we also showcased you how using the AVX accelerators, you can see a significant speed up in your RAG implementations on vector databases. I will pass this back to JP for the demo.
Thank you, Akash. So as promised, we will jump into the demo. We will connect all the tools that we have presented during this presentation. We'll see how these two applications that I mentioned, OpenSearch and Kubeflow, can be leveraged together to provide a RAG workflow. We will leverage the capabilities of the Intel accelerators in this demo, and everything that we will show is running Azure Cloud. So that's how everything gets connected and how you can build the end-to-end RAG workflow with all the dots that we presented. So I'll jump to the terminal so we can see a little bit of the interaction with it. So first, I'll highlight that it's important to remember that UJITs are a lifecycle operator for applications that we will use in order to interact with any cloud. In this case, we'll be using Azure Cloud. So the cloud that we are building a control against, it's going to be Azure. And we have two components here that are going to be relevant. The first one is going to be the Azure VMs that we'll use to leverage OpenSearch, for example, and the Azure VMs that we'll use to leverage microcades on top of these VMs. So we have used two models that are relevant here. So we can check the first one that it's going to be our OpenSearch model plus TLS integration, so we can provide everything around certificates and the security that we expect on the application layer for OpenSearch. The second model, it's going to be a abstraction of the key-serve application inside the Kubeflow environment, the Kubeflow platform. So this one is the one that we're going to use to infer our LLM and have our LLM under our control, as we saw in the slides. So if you see, you can detail the different logos of the applications that will be engaged in this end-to-end workflow. The first thing to showcase is, I said, we'll be using Keyser to infer LLM. In this case, we'll be using BLM server to provide a OpenAI compatible API, and this is going to be an isolated component under my organization's control. So I am inferring my own LLM. It can be a public LLM that you feel confident to infer and use as your the selected LLM. It can be an LLM that you fine-tune using the model trainer tool from Kubeflow. It can come from multiple places, but the important thing it's an LLM that it's under your control. So I can interact directly using this API, this endpoint that it's provided by the Istio gateway inside Kubeflow, and in the same way, as I said, it can be connected to OpenSearch in order to provide a connector that allows me to interact with the same LLM, but this time using the OpenSearch API. So instead of interacting with the API for the LLM, I can directly interact with I can interact through OpenSearch with the LLM. And trying to provide that example, let's ask this question that started this presentation: what is an LLM? I am using a Llama 2 model. It can be considered as maybe an updated model that maybe doesn't encompass everything, all the context that we need when we ask, for example, for an LLM. So as you see here, we are getting a misleading answer, at least for this context. It's answering that an LLM, it's a master in laws. But as we presented in this scenario. We are pulling someone into a conversation. The conversation is about AI, so LLM is not that in that context. So how we implement the RAG workflow as part of the solution in OpenSearch. So the next step is to provide and ingest documents that are relevant to be able to provide the right context to the conversation. So here it's where we are leveraging the power of the Intel accelerators inside the selected VM families. So we can use two important tools from the OpenSearch suite of tools. The first one, it's going to be the capability to create or infer a sentence transformer to be able to, from text chunks, create embeddings. And it's being performed in OpenSearch and accelerated with the Intel chip. And what we get, it's the vector that maps, or the high dimensionality vector that represents that sentence for that particular embeddings model. The second step, it's once we have ingested a lot of documents that we can add to the context, being able to perform neural search that are also accelerated thanks to the technologies that Intel is putting in place. In this case, we are using the AVX2, FICE engine accelerated that OpenSearch also enables you to use Lucene that can be accelerated with AVX 512 and use all the up-to-date current SIMD capabilities of the Intel chip. Akash maybe can add us a little bit of information of what's happening here and why Intel and the Intel power plays such an important role in to get this right.
Yeah, most certainly, JP. So as you saw in the second line before that, where JP showed that you have a lot of data that comes in, right? Like that's essentially floating point data that you're seeing on the screen. Now, what's happening under the covers is when a query gets issued from your RAG pipeline, like any question to the chatbot, that question is effectively converted into a floating point array. And when that floating point array reaches the system for the query processing, that's going to perform a very intense mathematical calculation against what the data that is already there in your database, the vector database. Those types of operations are typically dot products, the cosine products, etc. And they involve heavy computation. What we do with AVX2 and AVX 512 is essentially try to parallelize this type of a computation. And that is effectively what gives you the speed up that you would be seeing in your end application. So imagine running not just one query, but if you had thousands of such queries hitting your system, there would be a lot of computation going on in parallel. And if you could break that query down and process it even in a more data parallel way using AVX2 or AVX 512, you would see improvements in your end application, meaning the response time of your responses from the RAG pipeline will be much faster. That is the magic of AVX2, AVX 512 acceleration that happens under the covers, which results in improvements in the end pipeline.
Thank you, Akash. So, trying to concatenate the story that we tell about the email being the context, this is the context that it's going to be delivered to the LLM. So, it can be confidential information that's going to be passed. Now, with this context and using the tools that OpenSearch can put in place, we can enable an ML agent that it's going to, let's say, close the loop between the question of the user retrieving the information that was previously ingested, transformed using these accelerations. And now that it has the context, provide that context as part of the prompt to the LLM so it can provide the right answer, the precise answer in that context. So to the same question, what is an LLM? Once we provide the context that was retrieved using the neural search, the LLM is going to provide an accurate answer on the context. So in this case, an LLM, it's what we expect to be a large language model that it's trained for very large data sets, etc. So this is what we expect. But now, why it's important to choose the right tools? It's not only providing context to it. It's not only copy and pasting the information that can be used to augment the response of the LLM. It's also the relevance of being able to provide airbag to my solution, being able to provide a high available solution, a solution that I can monitor, and more. So let's do a second example using a different question. In this case, apart from the RAG basics, we added a guardrail that want to eliminate the bias of the answers. So I will ask the question that what is the best line of distribution? So as part of the answer, I expect the AI assistant to be very emphatic on the amount of analysis that it needs to take to provide a unique answer. And in this case, we expect to have a broad answer, something like, I need more information. I would like to know more about what you're looking for in order to provide you a concrete answer, something that it's specific, or tailored, or recommended for your environment. So since I also want to build a conversational tool, I don't want to be a question, answer. I want to be able to have a conversation with this tool. We integrate the memory capability, the chat history capability to OpenSearch, so we can use the memory that it's being built for this new conversation thread, pass that information as the memory ID for the next question, and to the question, what is the best line of distribution, let's add a second message to the chat. So, okay, you can tell me which is the best line of distribution, but what about if I'm trying to use a line of distribution to have confidential VMs in Azure Cloud? So it will merge all the things, the question, the guardrails, the context, and the chat history to provide me the following answer. And the following answer will get some of the information that we have give during this presentation. And it's going to say that Ubuntu confidential VMs on Azure may be a suitable option for confidential VMs, since your environment it's Azure Cloud. So that connects all the dots. So as a conclusion of this workshop, the LLM applications, being able to leverage LLM applications in company environments, in enterprise environments, is not only a technical challenge, it's also a data governance challenge. And putting the right tools in place will enable you to get the best experience out of Gen AI in boosting your productivity, boosting the productivity of your teams. That's why OpenSearch, it's so flexible to enable accelerators, but it's also so flexible to integrate with, for example, external authentication systems like Azure Intra ID and others that can be built around to provide a real enterprise-grade application. So that's what we have to present. Thank you very much for the time you spent with us in this workshop. And I hope this helps to guide your journey into building RAG end-to-end workflows using open source solution, using Intel accelerators, and hopefully building them on top of Azure Cloud.